This video is about evaluating and simplifying expressions. Okay, so we're just going to start with an example here and then we'll get into some definitions. So the example shows us that evaluating algebraic expressions just means that we're going to plug in a number, a specific number, for the variables that we see. And those numbers have to be given to you. So in this example, it gives us that a is -3 and b is 5. And we're going to substitute those values into this expression anywhere that we see a and b. When I do so, I'm going to put parentheses around the thing that I'm substituting. So you'll see how this works. I'm going to start with this 6. Inside of these parentheses, I have a plus 2. The a is -3 in this example, and I'm putting that -3 in another set of parentheses. It is okay to have parentheses inside parentheses, just to make it clear what number I substituted in. Continuing with the rest of the expression, I get all the way over here where I see the b, and I replace it with a 5 in parentheses. And that's really to make it clear that this is 3 times 5, and not the number 35. All right, and then I continue to the end of the expression. And now I just have to simplify this and find the value of the expression, which is why it's called evaluating. So I'm going to do what's inside of the parentheses first, which the order of operations tells us to do. So in here I have an addition problem, -3 plus 2, which is -1. Continue to write the rest of the expression. I'm going to perform this one step at a time. There are no powers here, no exponents anywhere, so now I can go to the multiplication step. I've got 6 times -1 and 3 times 5. We can do the multiplication at the same time. And now we have only addition and subtraction, which we perform from left to right. So -6 plus 15 is going to be 9, and then 9 minus 5 is going to be 4. So you'll notice the answer to this is just a number. There's no variables left in this because we substituted numbers in for the variables and then simplified. So to define what we just did, to evaluate an algebraic expression, you substitute a specific number in for each variable and then simplify the result. So just another quick and simple example. In place of the x, we put -7. Perform the multiplication first and then the addition. So 2 times -7 is -14. -14 plus 4 is -10. Two important notes. You should use parentheses when you are substituting and always obey the order of operations. You will get a different answer if you don't do your multiplication and division before your addition and subtraction, for example. So let's plug in this -1 for x and follow the order of operations here. So in place of x, I'm putting -1 in parentheses. This one has an exponent. That's what that little 2 is. All right, now I'm going to simplify using the order of operations. So inside of the parentheses, any operations that are inside of the parentheses you want to do first. So -1 plus 2 is just 1. Notice I'm not doing the 6 times -1 yet. Some people think of that as parentheses as well, but it's actually a multiplication step. And the order of operations says evaluate what's inside of the parentheses, and then exponents, and we have an exponent over here, so I'd like to do that next. So this exponent, 1 to the second power, notice it's not -3 to the second power, it's only the 1 that has the second power on it. So 1 to the second power means 1 times 1. So this is really just saying -3 times 1. And now we can perform the multiplication. So -3 times 1 is -3. 6 times -1 is -6. And now we can simplify from left to right. -3 minus 6 is -9. Minus 7 is -16. To get further into defining what powers and exponents are, so a power is repeated multiplication of the same factor. So for example, 5 to the 3rd power. This whole thing is called the power, and the power consists of 2 parts, a base, which is the 5, and an exponent, which is the 3. So the base is the number that is being multiplied by itself. It's the factor that's being multiplied by itself. The exponent tells you how many times to multiply it. So 5 is the base, 5 times 5 times 5, because 3 is the exponent. And then 5 times 5 times 5 is, of course, 125. There is a difference with the placement of a negative, whether it's inside of parentheses with the base or outside the front of the power. So when you have a negative that's inside of the parentheses, that means that the base is negative 5. So the base of negative 5 is being multiplied by negative 5, is being multiplied by negative 5, is being multiplied by negative 5. And that's actually how it looks when you look at that expression. The negative 5 is the base. It's being multiplied by itself 4 times, which is different from what we have on the right. On the right, we have a negative in front of the power being the entire 5 to the exponent of 4. And the 5 is the base. It's just a 5 times a 5 times a 5 times a 5. On the left, we end up with a negative times a negative is a positive, another negative times a negative is a positive, and 25 times 25 is 625. On the right, 25 times 25 is in the parentheses, but there's a negative in front of it. Completely different answers, based on whether or not you have parentheses around that negative or not. So pay attention to which situation you're in. Further examples of this, so evaluating powers, just to practice, 4 to the third power is 4 times 4 times 4. Negative 2 to the fourth power means that we're going to evaluate the power, so 2 to the fourth power, and then stick the negative in front. So negative 2 times 2 times 2 times 2, which is negative 16, versus negative 2 to the fourth power, which would mean that the base itself is actually negative 2. So we have a negative times a negative times a negative, and that's a positive. Be careful with exponents when you're evaluating an expression. So that rule that we just practiced, you have to be really careful when you've got a lot of x's and a lot of powers in your expression. So make sure you're using parentheses when you substitute. In place of this x, I'm putting negative 3. In place of this x, I'm putting negative 3. And now first I'm going to simplify what's inside of the parentheses, just like the order of operations tells us to do. So negative 3 plus 1 is negative 2. So I have negative 2 in parentheses to the third power. And then I have minus negative 3 in parentheses to the second power. So this is when it becomes extremely important to use parentheses when you substitute, because that placement of that negative really changes the answer like we just demonstrated. So negative 2, when it's in parentheses to the third power, means a negative 2 times a negative 2 times a negative 2, which is negative 8. Subtract. Negative 3, when it's in parentheses to the second power, is negative 3 times negative 3, which is positive 9. So in the end, the value of this expression is negative 8 minus positive 9, which is negative 17. Okay, and then the second half of this lesson is about simplifying algebraic expressions. And in these, we don't have any values for x or y or a or b. We're not given values. We're just asked to simplify what is given to us by basically combining like terms. And I hope that's something that you've practiced before. Like terms are like x's can be added to other x's, and y's can be added to other y's. But x and y can't be added together. It's like apples and oranges, the analogy that's usually given. So when you're looking at an expression and you're just told to simplify it, you're basically looking for things that you can combine just to make it look a little simpler, shorter. So we've got a 7x to the second power and a minus 4x to the second power. And those are like apples and apples. We can combine them. So 7x squared minus 4x squared is like having only 3x squared, because 7 minus 4 is 3. And then we've got y squareds that can be combined. We've got positive 3y squared plus 2y squared. So this is like we have 5y squared altogether. Notice I didn't change the value x squared or y squared at all. I'm just combining some number of x squareds and some number of y squareds. And this is the simplified version of that, and that's it. So this is different from evaluating. Notice our answer still has the variables in it. So let's define what we just did. Algebraic expressions consist of numbers, variables, operations, and grouping symbols, no equal signs. So notice if I go back a slide, this has no equal sign in it. You are not solving this at all. It's just an expression that kind of stands on its own, could be evaluated later on if somebody were to give you x and y. But just really note that an expression has no equal sign in it. So this is an expression. 4x on its own, it's an expression. In fact, even just the number 4, that's an expression. As soon as you have something like x plus 2 equals 10, well, that's called an equation, and that's not what we're practicing here. The parts that we added together in that expression were called terms. You could have variable terms or constant terms. So this is like if you have 2x plus 5 plus 3x plus 1. The 2x and the 3x are called variable terms because they have a variable in them. And the 5 and the 1 are called constant terms because they're constant. They don't have variables, they never change. The like terms here are the 2x and the 5x. The 5 and the 1 are also considered like terms. A number that is multiplied by a variable is called a coefficient, in case you're ever asked to define that word. So in something like this variable expression here, we've got 2x. The 2 is called the coefficient. You'll probably hear us use that word a lot. The x, of course, is called the variable. Like terms, which I sort of just introduced on the previous slide, like terms of terms that have the same variable and the same exponent, or constant terms would also be considered like terms. So if you have 3x squared, 5x squared, plus 2x minus 3x, plus 5 plus 1, these are like terms because they have both x second power. These are like terms because they have both just x. And, of course, these are like terms because they're both constants, and 5 plus 1 is just 6. So you should be able to visualize what you can combine here. So to simplify any algebraic expression, you're just combining the like terms by adding their coefficients together. So 5x squared and 3x squared is 8x squared, plus 2x minus 3x ends up being just minus x, and then 5 and 1 ends up just being 6. So you've simplified it down as far as you can by combining all of the like terms. Just to practice a little bit more, I hope you can identify 3p and 5p are your like terms here, and negative 2 and positive 7 are your like terms. You get it down as far as you can and then stop. 2x squared and minus 5x squared are your like terms. Positive x and minus 9x are your like terms. And then, of course, putting it all together, you might have to do some distributing negative signs before, or numbers, before you combine the like terms. So here, in this first example, I see x and I see x somewhere else, but I can't combine them yet because they're stuck in these parentheses. I see things that need to be distributed first, which is to say that this 4 that's in front of the parentheses actually does need to get multiplied by both the x and the minus 5. That's because the parentheses has the subtraction sign in the middle. When that's the case, you have to distribute anything that's in front of the parentheses by everything that's inside. So 4 times x is 4x, and 4 times 5 is minus 20. Continue simplifying the other set of parentheses. Negative 3 times x, negative 3 times 6. And now it's an expression like the ones on the previous slide that we can simplify. So 4x minus 3x is just x. Negative 20 and negative 18 is minus 38. And that's as far as we can go. Practice one more time over here. We have 8 times d and 8 times f. So 8d plus 8f. And then just note that if you ever have a minus sign in front of your parentheses, that's like distributing a negative 1. So negative f, and the negative 1 times the minus d becomes a plus d. And now I have 8d and another d, so 9d. I have 8f minus f, so 7f. And that is all.